Hey everybody, this is Larry. This is day 3 of the November. Whoops, wow, time just keeps flying by. To November Leetcode Daily Challenge, hit the like button, hit the subscribe button. Join me on Discord, especially if you like contest problems and Leetcode problems and so forth, and just, hanging around with smart people or me. Anyway, today's problem is some root to leaf numbers. You're given root, okay, you represent number, okay, that makes sense. We're doing the sum, okay. Yeah, that should be pretty straightforward-ish. Yeah, I mean, I think this is so the way that I always think about these trees, or maybe not always, but the way that I explain it in any case is thinking about it. Okay, start. The tree is a complicated subject or complicated data structure, or at least maybe until you get used to it a bit. So the way that I think about it is think about a linked list, right? Okay, I know linked list isn't that much easier. I don't, or at least depending on the problem, it's not always easier. But for this problem, think of a linked list, and then when you think about linked list, think about an array instead, right? And in this case, you just think about, okay, what happens if you have an array, right? So for example, let's look at a tree. Let's say you have this tree right here, right? 49051, right? So then you go from 495, and then you remove the last digit, and you add 1, and so forth. And then you kind of go back, and then you put in the 0, right? So these are the ideas that I would think about. If you're having trouble with these kind of problems, these are the ideas that I would think about. And then thinking about it, how to do it for a linked list, and then just pop it off one at a time or something like that, either off the explicit stack or an implicit stack by recursion. So, okay, I think that's all I need to do. There are a couple of ways you can do this. One with global variable, and another one just by returning the sum of the numbers. I'm going to use the sum version just because I think it's cleaner, even though it is a little bit more confusing if you ask me, possibly. Or when you're coding, or for this one, it's pretty okay. But when it gets more complicated, it is a little bit trickier. But if you practice enough, it should come at least more of a thing. And actually, so yeah, I mean, I think you can actually just use this directly. So maybe we do that. Okay, right. So total is equal to 0. So if root dot left is none and root dot right is none, we return. So this is the child, right? Oh, actually no, we can't do it this way. I forgot that. Never mind me. So we have another one with a so far digit. Something like that, or current, something like that. And then here, so we have a couple of cases, right? Which is if this is a leaf node, or maybe if node is none, we return 0, right? Yeah, because this node is none, and this should only happen if the root is none, to be honest. But yeah, otherwise, if it is a leaf, then if this is a leaf, then we return current. Otherwise we return total of node.left, current times 10 plus node.value, plus total.node.right, current times 10 plus node.value. Of course, this amount is just the next amount. Maybe I could put in a variable as well. Yeah, shifted, maybe you could call it that. I don't know, that makes sense. But it's just basically the next number, right? Taking account the current digit. Yeah. Is this right? No, I think this is wrong, actually. I mark it up somewhere, huh? Because basically if this is leaf and we calculate beforehand, then this should be wrong, actually. So I think actually this is which way do we want to do? Do we want to calculate before or after? We just have to be consistent. I think both ways doesn't really matter as long as you're consistent. So here we just do plus node.value. And then here we can just return total root and then 0 because now it doesn't take account that. And that's pretty much it. You can actually still use this thing if you really wanted to change the parameter by adding an optional parameter, but I think that's a little bit sketchy. Also, I'm really wrong apparently. So Where did I go wrong? Where did I go wrong? Do. Man, I was just saying how easy it was, and then I just messed up. Okay. Huh. That is... Oh, I'm just being dumb. Well, I mean, it still might be... Oh, yeah, I'm still just being dumb because I forgot to shift at all. So we definitely still need to shift. Yeah, okay. I don't know why I thought... Yeah. We still need to shift, but we also need to shift here, I think, is my point. Whoops, here. Whoops. Huh. There you go. Let's put in some test cases. Some edge cases. Was it none or no? What is the thing that they prefer? Something like that. Tree visualizer. This, yeah, that looks okay. So 1, 2, 3, right? Okay, so that looks good. Let's give it a submit. Cool. 582. Nice. Yeah. So this is going to be linear time, linear space, linear time because we look at each node at least once, and as a matter of fact, the lower bound is O of n, right? So it's going to be because you have to look at each node once. So you at least look at each node once, and you have to look at each node once. So it's going to be linear time because you have O of n nodes, and linear space or O of h space where h degenerates to n with you're giving a linked list essentially. Where h is height maybe, so that's just a stack space. So yeah, that's pretty much all I have. I think this is relatively okay as long as you don't make silly mistakes like I did. Let me know what you think. Anyway, I'll see you later. Stay good, stay healthy, to good mental health. Hit the like button, subscribe button, join me on Discord, and I will see you later. Bye bye.